Hey guys, this is Tutor Me MATLAB, and today we're going to talk about vectors and vectorized code. First of all, what is a vector? Well, you've heard about variables from our previous videos. So a vector is just a special kind of variable that can hold a list of numbers. Pretty simple, right? How do you tell MATLAB that you want to create a new vector? Well, you give it a name, kind of like any other variable, and to tell MATLAB that you want to start a new vector, you have to write open square brackets and then a list of comma-separated numbers that will be stored inside the vector. So let's say my vector v will have the values 12, 13, and 14. Now v is equal to a list of 12, 13, and 14. If I want to access these numbers individually, um, I can ask for them uh, by saying variable name, open parentheses, and then the index of the number we want to access. So if we want to access the first number, we say v, open parentheses, 1, close parentheses. It'll give us the first number. If we want the third number, we can say v of 3, and it'll give us a third number. So MATLAB has these essentially functions that you can apply to vectors that will help us out when we're using vectors. So the first one that we want to talk about is the length function. You just write length and open parentheses and give it a vector, and it will tell you how many elements this vector has. In this case, vector has 3 elements. Also, the sum function. So what the sum function will do is it will add each element of the vector individually and return the sum of those elements. So sum of v is 39. That's 12 plus 13 plus 14. So if you've heard the terms vectorized and non-vectorized code, probably because your professor covered it in class and you're not sure what the difference is and what's vectorized and what's non-vectorized code. Essentially, vectorized code is whenever you apply an operator to a vector and do something to the whole vector at the same time. What are some examples of this? So let's say you have the vector v and you want to add 5 to each element individually. The traditional way will be to use a for loop, right? We've covered for loops in the past. So we have a vector v equals 12, 13, and 14. And then we'll do a for loop for I equals 1 to 3. V of I, so this will iterate, I will be equal to 1, 2, and then 3. So v of I equals v of I plus 5. And then let's just display v. If we run this code, simple vector, we'll see that v plus 5 in each element is 17, 18, and 19. So that's non-vectorized code. Every time your professor asks you to use non-vectorized code, you need to use a for loop. There's no other way around it. If you're not using a for loop, that's a pretty big indication that you're not using non-vectorized code, and you should have a for loop somewhere. So what is exactly is classifies as vectorized code? Let's see. In our simple vector example, instead of having this for loop, all we need to do is actually v equals v plus 5. And MATLAB will know if we're adding a vector to a normal number, then we should apply plus 5 to each element in that list. The minus operator also applies, so v equals v minus 5. This will get it back to normal. Display v again. Say v equals v times 5. Display v again. And then v equals v divided by 5. And display v again. So this will display v 4 times simple vector. So this is our simple vector. The first time we added 5, then we subtract 5 again, then we multiplied by 5, and then divided by 5. All these 4 lines that we wrote are vectorized code because we didn't use a for loop and we just applied the operator directly on the vector. So that's basically the difference between vectorized and not vectorized code. Okay, so I mean, why do we want vectors, right? Like, why do we need it? Why can't we just store each element individually in a variable? Well, it turns out that it makes programs a lot simpler to write and a lot more flexible. Um, let's have a concrete example. Let's say that we want to write a program that will calculate the average of some of your test scores. So I already wrote a couple of these lines. So the variable scores will be a vector where each element of the vector represents one of your test scores. So my first test, I got a 90%, then a 40, then a 35, then a 20, lastly 100. My strategy for this was to essentially sum up all of the elements in the vector, and then divide by how many elements I had. So the non-vectorized version, I need a for loop, so that's how I'm starting. I have a for loop from I goes from 1 to the length of scores. Now that's very important because I don't know how many tests I took, and I want this program to work no matter how many tests I give it. So I don't want to give it a hard-coded value like a 5. I want it to depend on the length of my vector. So for I goes from 1 to length of scores, total equals total plus the current score that I'm looking at, and then end. After this for loop, the value of total will be the sum of all these numbers, and then average will be the total divided by the number of tests that I took, and then I'll print my average score. We save this. Now let's CLC. Vector lesson. Average score was 57%. So if you do the math, it'll be the same thing. I can change, I can add another test that I got a 20 on, and then a 50 on. I'll save, and let's show you. Okay, so I have, I added these two values, 20 and 50, and if we run the code again, my average will drop because both of the test scores that I added were below my previous average. So that's the non-vectorized code. Can we make it a little shorter? Well, with vectorized code we can. Let's see how to do that. I have my test scores. I won't need my total anymore, actually. I don't need a for loop because I'm using vectorized code, so let's call it vectorized example. So my average will be the sum of scores divided by the length of scores. Sum is vectorized code because we're adding each element kind of in the background, so we're kind of getting around the whole trouble of having to access each element individually and whatnot. So alright, let's try that. Vector lesson, and I get the same answer with less lines of code. So this is a vectorized example when I just have sum of scores divided by length of scores, and it's pretty straightforward. So yeah, I guess those are vectors. That's pretty much it. Alright, thanks for watching, and please like and leave some comments on how I can make these videos better. Thank you.